There's a circle, containing a circle, containing a circle, containing a circle, containing you, a circle, made up of smaller circles, made up of smaller circles, made up of smaller circles. I want to see something smaller, the smallest I could find. Said who? Said a man named John Dalton. He adapted ancient Greek theory into the first modern atomic model. What's this? You wanted something even smaller? Good thing J.J. Thomson was curious enough to find
Electrons?
it's what determines the charge of an atom. Why, you ask? Ask Rutherford in his planetary model of the atomic structure. Just look at it. Here's the sun. No, that's the nucleus. Massive. It takes up most of the atom's mass. What's in it? Protons and neutrons. Protons are positively charged, while neutrons are neutral. Where's the negative charge though? There are the electrons. They're outside. They are moving and moving and moving, sometimes leaving the atom to join a new one. It's sad, but it's okay. We lost negativity. Now the atom is positive. I'm sad. This is the periodic table of elements. It is a table with periodic system containing elements. This is an example of an element. This is how you determine the most basic characteristic of a said element. Starring A as the mass number, Z atomic weight, and X as the element. Sometimes, atoms can have different ratio of electrons to protons, and these are called
Ions.
Atoms bond with other atoms. They react differently depending on the change it made to their electrons. Some are too positive about losing electrons. Some are too negative about gaining them. While some don't give a shit since it didn't lose nor gain anything. I'm telling you this so you learn. So that's an S with 4 O's. Sulfate, an example of an anion, means it's depressed and sad. It has a negative 2 charge. Will losing electrons make me positive? Said the atoms. The answer is yes. Now we have cations. Let's remain electrically neutral by retaining the number of electrons. That's what you call molecules, biz. Now let's start naming compounds. When you see only 2 elements, that's a binary compound. If there is 1 metal cation and 1 metal anion, just get the name of the metal and add the suffix "ide" to the identifying term of the non-metal. These compounds are ionic compounds. Some ionic compounds form 2 or more types of cations. Stock system is used in naming these. Just add the suffix "ic" to the classical names with higher charges of metal cations, and the suffix "os" to the lower ones. Then, add the suffix "ide" to the non-metal anion. Or you can simply just add the Roman numeral of the number of the charge of the cation. Some compounds can be of 2 nonmetals. These are covalent compounds. When naming such, just add the prefixes mono for 1, di for 2, tri for 3, and so on to elements in the compound, and add suffix "ite" to the identifying term of the anion. Some hydrogen compounds have acid properties when dissolved in water. Binary acids are compounds composed of hydrogen and a nonmetal element. To name these, add prefix hydro and suffix "ic" to the stem name of the nonmetal and add acid after. Some compounds contain more than 2 elements. These are called polyatomic ions. When they contain oxygen, they are called oxyanions and have suffix "ate" for higher oxygen count and "ite" for lower ones. Some, however, form more than 2 oxyanions. To name them, add prefix "per" to indicate higher oxygen count than 8 form, prefix "hypo" for lower oxygen count than 8 form. Acids made with these anions does not need the prefix hydro. Just add suffix "us" to lower oxygen count, suffix "ic" to higher ones, prefix "per" to higher oxygen than "ic" form, and prefix "hypo" to lower than "us."